Looking at example 5 on section 3.1. Try to find this limit. We're asked to find the limit as x approaches 2 of x squared plus x minus 3 over the square root of x plus 2. Okay, really what this problem is showing us is that all those rules that we just saw, and I'm going to go ahead and just write them this time just to show exactly how these rules are used. And at the end we'll see that really all this amounts to is the fact that as long as we don't have to divide by 0 or take the square root of any negative number, all we really have to do to find this kind of limit is simply plug it in. But really, if we look at all of the rules together, there's a rule that we saw in the last example that says if we've got the division of two functions, we can write that as the quotient of the limits. So, in other words, this is what we can do. We can take the limit of the numerator, we can take the limit of the denominator, and then further, there's rules that say that if we've got square roots, we can basically put the limit underneath the square root, and I'm trying to see which one that rule is. Yeah, that would be rule 6, keeping in mind that if we have a root, that can also be written as a power. Just note that the square root of x plus 2 can also be written as x plus 2 to the 1/2 power. So really that's just saying that roots are in fact powers, so we can treat them as is shown in rule number 6. There's a rule that says that if we've got the sum or difference, we can simply take the limit of each part individually. So we'll do that. One limit plus another limit minus another limit. Again, this is the only time we're actually going to do it like this. Really, all we have to do is simply plug the value in, as long as we're not going to end up dividing by 0. So let's go ahead and write that as a fractional power so that we can use that other rule. Say this is the same as the limit as x approaches 2 of x plus the limit as x approaches 2 of 2. And then all of this is to the 1/2 power. So really, again, this is just showing what these rules are allowing us to do. We can now find all these limits individually. And in fact, there's a rule on there for what happens if you've got a limit of something raised to a power. Basically, it's the same thing as if I took the limit of this thing and then raised the limit to that power. So I'm going to skip that step. At this point, really, all we have to do is say, well, what's that limit? It's 2 squared. What's that limit? Well, again, if I just plug in the number 2 there, it's just going to give me 2, so plus 2. And then the limit of a constant is just itself. In fact, I believe that's one of the rules on here as well. Let's see if we've got that one on. Limit of a constant. Nope, that's not on there. But anyway, if you've got a constant, its limit is simply itself. This one, 2 plus 2. And again, remember that this was 1/2 power, but that's the same as the square root. So this is what we're going to end up with. 4 plus 2 is 6, minus 3 is 3, and then 2 plus 2 is 4. Square root of 4 is 2, so at the end we get 3/2. What we could have done, if you notice, if I simply would have just plugged 2 in right away, just gone right ahead and plugged 2 in, look what happens. I get 2 squared plus 2 minus 3. That's that. If I plugged in 2 there, 2 plus 2 is 4, I'd get that. So this example is just to show kind of how these rules are being used, but from now on we're basically just going to skip this step here and say, all right, well, again, as long as I don't end up dividing by 0, taking the square root of a negative number, anything like that, all I really have to do is just plug the number straight in.